Good evening, everyone. Okay, I take it that everyone can hear me because I can definitely hear myself. So I'm just going to kind of introduce the whole issue with the informal settlements, what there are, what they look like, and then also a little bit about the fire problem, and then one of the projects that, I certainly think has got a lot of potential and has been quite successful in the communities that we've implemented it in. And then Richard will go into more detail with regards to some of the research that we have been doing and hoping to do in the future, and potentially with other collaborative work with universities like yourselves and others. So, where do we come from? Well, I hope you all know where South Africa is. It's obviously in Africa, the bottom of the continent, right at the bottom of the continent. You'll find... goodness, where's this laser gone? Okay, you can't really see the laser. Oh well. Okay, well, maybe I'll just use my hand. So this is the country. It's made up of 9 provinces. Provinces are like your states. I'm responsible for this province here at the bottom, the Western Cape, and that's Cape Town right at the bottom. So that's Cape Town. That's what it looks like. It's a beautiful city. Surrounded by mountains, Table Mountain here in the front, and ocean, and very similar looking to any other wonderful city or developed city in the world. But there's massive inequality. There's gross inequality in South Africa all over the place. So with this, we also have these sprawling informal settlements, what are sometimes known as slums, where there are very poor people that have come to seek work, jobs, to earn some money, and cannot afford to rent a property, a house, or an apartment, and have to unfortunately build a dwelling literally out of scrap materials like you see here. Some of these people do live here permanently with their families. In fact, many do, with their children. Others have moved down from other provinces to find work, and then even others have come down from other countries to work in South Africa and in Cape Town in particular. So these structures are made of different materials, but typically corrugated iron, as you can see up there and down over here. So these sort of corrugated metal sheets, as well as wood. These little wooden shacks or dwellings that are interspersed between them. You'll notice that there's burglar proofing and security gates because crime is an issue pretty much throughout South Africa, and in particular in the informal settlements. So these are highly combustible dwellings that can and often do burn. They use a blend of energy sources. If they don't have access to electricity anywhere nearby, they'll typically use the paraffin stove, which I guess you'll call a kerosene stove, which are often made in China at very low cost so that they can afford to buy them in South Africa. And unfortunately, they don't last very long, but they continue to use them, and often that creates a problem where it ruptures and the flammable liquid will leak out, or it'll fall over and catch fire and spread that fire throughout the dwelling and the informal settlement. They also use gas over here, but there's no enforcement of codes or standards, so often the installations can be quite risky, just using wire to really connect the hose to the gas cylinder and the stovetop. Then we also have electricity. On many occasions, that electricity is illegal, so they'll tap into a street pole or street light in a street nearby and connect up and run those cables throughout the informal settlement. But many of the informal settlements in Cape Town, at least, do have access to electricity, so they'll have a distribution box inside the dwelling, but unfortunately, they often then just run off additional wires from that distribution box, have open connections and appliances that are in need of repair or maintenance that can also contribute to the fires. Amongst other things like paraffin lamps, candles, children playing with matches, and a whole host of other hazards that often lead to this, fires. So this was a real fire situation. There was a series of photographs were taken by one of the photographers that volunteers with the fire department. And he goes, we allow him access into these areas, and he takes some really good photographs, which we use for various reasons. In this case, you can see this cardboard sort of cladding on the walls, which they put on the walls to create some kind of insulation, especially in winter, to try and keep the environment warm. But you can see that there's a lot of flammable materials in this type of environment. It doesn't comply to any kind of code or standard, and there's no enforcement. So this is really just a time bomb waiting to go off. The result is that the fire department, as you can see there, struggled to get access into these environments because they're all built next to each other. There's no access roads, or if there were access roads, they're often built over by other shacks. We find that we can't access hydrants because either there's no hydrants, because it is an informal settlement, so there was no planning that took place to begin with. If there were hydrants, they're often vandalized, or in fact, a shack could be built literally over the hydrant. So we rely a lot on tankers, but as you can see, a lot of their goods and belongings are now in the street, creating a massive challenge for the fire service to gain access into that area. The result is that people take the situation into their own hands, often fighting the fire themselves. Here you can see this gentleman's trying to save his little shop from the approaching fire with a bucket of water by himself. Unfortunately, that's often not very successful by the time the fire has got to that stage, and he literally has to then just evacuate and watch all his belongings go up in flames. It escalates to a point where often the community wrestle the firefighters for the hose and literally take it away from them so that they can then try and get to their own properties to save their own properties. You can see that in this situation, this person doesn't have any protective clothing. He can't even face the fire. He can't even see the flames because of the heat. So any kind of firefighting effort is ineffectual. Others will come and help each other to try and protect their properties or wrestle the hose from each other. Unfortunately, none of that actually works at the end of the day. So they resort to breaking down their dwellings before the fire gets there so that they can save some of the materials in the hope that they can use those same materials after the fire has swept through the informal settlement to rebuild their homes. In this case, they've managed to take out the belongings and are now trying to protect those belongings from the fire. But often what happens is either the tankers run out of water, or they stab the hose with a knife to get water, wherever that hose is, onto their own properties. And by that time, there's either no water left, or there's certainly no pressure left at the end. And they will literally have to just watch everything burn. As the fire moves through that informal settlement, people will just have to evacuate. And unfortunately, with great despair, firefighters can't do much in that kind of chaotic situation other than get people out and literally watch everything burn to the ground, which often leaves many dwellings destroyed, hundreds of dwellings destroyed, and thousands of people displaced. So unfortunately, we've now got the reputation in Cape Town to be known as the fire capital of South Africa. And there are many reasons why that is the case. We have, throughout the country, we have one of the highest fire fatality rates in the world. It's about 8.5 per 100,000, which is greater than the African average of 6 per 100,000. And in Cape Town, we pretty much have somebody dying in a fire every single day in the informal settlements. So we've had to look at this complex problem holistically, or as holistically as possible, moving away from a reactive focus and just responding to these incidents, and trying to look at it in a more proactive way, working with other organizations like universities, like Stellenbosch universities and Dr. Walls, and social scientists, so that we can really understand the root cause of this problem. Because it's not those fire hazards in those dwellings that are really causing this problem. It's a lot deeper than that. So one of the models that we used is the ecological model, which kind of dissects all the different levels from a social perspective and looks at societal issues as a whole, community, relationship, household, and individual. And it helps us to identify specific issues related to each of those levels, like poverty, because essentially this is as a result of poverty, of people not having the money or the resources to live in a safer environment, or to obtain the resources to make it safer. Things like high unemployment, alcohol and substance abuse, age, gender, amongst a whole host of other things which I'm not going to go into at this point. But having a look at those and working with a lot of other organizations, we've also identified a lot of evidence-based interventions that we've divided up into the social, structural, and technological risks, the behavioral risks, and the supportive and institutional environments. And specific interventions that have worked elsewhere in other countries, or even in South Africa, or that we feel would be important to implement as a basket or a multi-pronged approach in dealing with this complex problem. So we have a strategic framework which we've developed to help organizations, fire departments, and other government departments to deal with this issue collectively, and that each organization can take their share of the responsibility in trying to reduce the fire deaths. So I'm just going to now go into this specific objective, 5 household warning systems. I'm just going to talk a little bit more about that. But just bear in mind that this is a much bigger strategy that we're looking at. So one of the things that we know is that most of these people, 70% of all of these fire deaths in these informal settlements occur during the sleeping hours, between the hours of 11 p.m. to about 5 a.m. with a peak at 1 a.m. So it's pretty much at night when people are most likely asleep. So we know from international research, global research, and in particular research here in the US, that smoke alarms have had a significant impact at saving lives, at providing an early warning of a fire situation in a home, and giving people enough time to escape. So, but what we don't know is, will this work in an informal settlement, in an informal dwelling? In South Africa, we have a funny situation where smoke alarms are only required in commercial properties and industrial properties, and not in domestic properties. So even though I have home smoke alarms in my own home, it's not required by law or regulation. So people don't even know what a smoke alarm is. There's no history of smoke alarm use. So this is really a first for us, and certainly when it comes to the use of smoke alarms in informal dwellings, we haven't come across any research that indicates any kind of success or use at all in those environments. So this is just a short video clip of, that's a paraffin stove that was left on for about an hour. It was pulled off with, you could see that string. Obviously bursting into flames as it hit the ground, and the stove itself ruptured, releasing the flammable liquid, which typically would be like a daytime fire, where somebody would be working or using the paraffin stove and may have knocked it over. They may even have paraffin on themselves, on their clothes. They could catch fire and obviously run out of this situation. But essentially, what we wanted to show here was how quick it takes for a flashover event to occur. Now, flashover is when everything in that particular environment catches fire and is engulfed in flames, even though it might not be in direct contact with those flames. So if you notice here in the front, you'll see this carpet, if you can see it from where you are. You see it starts to release some smoke and it starts to curl, and suddenly you'll see this flame flashing across in a moment there. That's probably when flashover has occurred, where everything is engulfed in flames and everybody dies, including a firefighter in full protective clothing with an SCBA. Now, historically in the US, in an average US home, flashover was about 8 minutes, I think in the 70s. NIST has done some recent studies that indicate that flashover in an average home in the US is now 3 minutes. So that's when that occurs, and that's all the time you really have to respond to that situation to try and save someone's life. In this scenario, it was just over 1 minute. So we know that whatever we do, responding to this kind of thing is not going to save lives. We're going to have to try and empower the people living in this environment to be able to detect a fire when it happens and try and give them the time to escape or deal with that situation themselves. So we wanted to test smoke alarms and amongst a number of other devices to see the impact that they could have. We built these shacks. We worked with a number of organizations, Stellenbosch Engineering and Dr. Walls, to test. In this case, these are the photoelectric smoke alarms with photoelectric sensors. These are ionization sensor smoke alarms, and these are rate of rise heat detectors. This particular scenario, we wanted to test the smoldering stage. It was important to test the smoldering stage where there's really just smoke that gets released over time. So one can imagine somebody sleeping, in their bed at night, and there's a smoldering fire that's happening. A lot of this toxic gas and smoke is being released. This was just a little contraption that Richard and his team came up with that could create that kind of scenario and release that toxic gas. We tried to seal this shack inside a building about this size, one of the training facilities. It got to the point where we had to evacuate the building ourselves and send in a firefighter with an SCBA to end the test for us. So what were the results? Well, here you can see temperature on that side and time at the bottom. You'll see the photoelectric smoke alarms activated first on the first sign of visible smoke, which correlates with other research that has been conducted. Photoelectric smoke alarms are designed to activate quickly for smoldering fires. Then what was interesting for us was that 30 minutes later, the ionization smoke alarms activated. And that's a little late in that kind of situation. Although ionization smoke alarms are designed more for flaming fires. Then, as predicted, the rate of rise heat detectors didn't activate at all because there wasn't much of a temperature change. So that was for the smoldering fire activation. Then if we look at the flaming fire tests, we used what we call the representative shack, and other tests as well. But with this one, basically a shack that has the contents of what you would normally find in a shack. So the cardboard on the walls for insulation, a bed, bedding, and you can see this container here is the container that they put the paraffin in, the kerosene in, that they use to fill up the stove with. So often these will also be, on a shelf or somewhere in that environment. Then we used this mbola, which is a 25-liter drum that they've knocked holes in, and then they burn wood and like coal or briquettes outside until it's glowing hot. They bring it inside and leave it inside for warmth throughout the night, kind of like the poor man's central heating that you all have here in the US. We don't actually have central heating, or certainly not in our homes in South Africa. So that was obviously fully engulfed. We put this boiler next to the bed. There was a sort of a smoldering stage, and then it obviously flamed up, and that fire spread rapidly. There's the thermocouples and all the other instrumentation. This is a short video clip. You'll see this sort of flamethrower effect here, just blasting out this fire in that environment. And what that is actually one of these containers that ruptured. So it kind of got heated up and then got to that pressure where it split open, squirting out that kerosene or that paraffin which caught fire. And one can imagine if somebody was trapped in that environment. And this is exactly what often happens, because by the time they do wake up, it's too late and they'll literally be burned alive. So with the different devices that we used, ionization activated first, which again correlates to international global research on the devices. It has been designed for flaming fires, but the photoelectric activated very soon after. The heat detectors only activated during the flashover event and not providing enough time to escape. So essentially, we used this data to determine what kind of device we were going to use in implementing it in the actual informal settlements. So that was the more technical research. We went through that whole process. We identified a device that we thought would be most appropriate. The detectors that we used also have a 10-year lithium battery, because we knew that people would not replace the 9-volt battery. They cannot afford to replace that 9-volt battery every year. And it also needed a silence feature to quieten the alarm if in a case of a nuisance, if they were burning some food or whatever the case is. So this is a bit jumpy. So in this particular informal settlement, the Zwela Themba informal settlement, it's bounded by a road. We randomly selected homes and we installed these devices. We used the fire department. They had a good, they had credibility within the community. There was already a trust relationship. So they also worked with a ward councillor, which is a politically appointed person within those communities to also assist the community. And there was a level of trust, obviously, with the ward councillor. And they went from door to door installing the devices. There was a lot of lessons learned through this process. The communities were very receptive and certainly wanted these devices installed because of the amount of fires that were occurring in this particular community. We then identified another community and decided to install a smoke alarm in every single dwelling. So this is the Wallace Dean community. There's 1,400 dwellings. We installed a smoke alarm in each and every dwelling. But this time around, we used the community themselves. So that's the community leader at the end there. There was already a lot of community engagement that took place within this community by the social science department within Stellenbosch with some other project. Fire was a risk, a significant risk in the community, and they were quite excited and more than willing to have these devices installed in the dwellings. So we also trained people from this community to conduct a survey, a pre and post survey, to obtain a baseline, and then we trained another group also from the same community to install the devices. And they went from door to door to install those devices in each and every dwelling. So, oh goodness. All right, yeah, if you can, thanks. So, in my view, I think this project was very successful. We had a lot of resistance to installing smoke alarms in informal settlements from a lot of different people, including fire chiefs. They said that it wouldn't work, that they would be going off all the time. But it had never been done, and there wasn't any previous research. So there were a lot of challenges. However, we did save lives. So you'll see there were about 9 fire incidents that occurred. These devices have been installed now for just over a year. And many of those incidents that did occur, lives would have been lost if it wasn't for those smoke alarms. So people were able to be aware that there was a fire or an imminent fire within their dwelling. They were able to wake up and get out. Or another thing that happened was that the community members next to them were able to respond. So for example, in the one incident, an elderly gentleman had been drinking, so he was intoxicated. He came home, put something on the stove, and then fell asleep. Whatever left on the stove obviously caught flame, activated the alarm. He couldn't respond because he was intoxicated, but the person next door did. So they can hear the alarm about 20 meters away within this community. And they were able to respond and kick the door down, take what was on the stove, throw it out, and essentially save his life. So we had a lot of different scenarios like that where people's lives were actually saved. And there was only one shack that burnt down to the ground. But they were able to contain it to the area of origin, to the dwelling of origin, preventing that fire from moving to any other shack, and were obviously able to rescue the person as well. There are a lot of other challenges with these devices in this environment. For example, insect infestation. That's something that we're looking at, and we're hoping to come up with a solution with a lot of different people that we're meeting with, both Stellenbosch and the OSU. So I think that's it. Yeah. So I'm going to hand over to Richard. And I think I need to give you...
if you can just give me the mic.
Which one? Going. This one.
Yeah. Got two of them on. Okay, well, just give us a sec. We're just swapping across. So, good evening, everyone. It's good to be out here. It's my first time in the States, so it's nice experiencing a slightly different country. Slightly. And looking tonight, I mean, also... sorry? Is it better with the light on? Let's see. It's better just looking at the screen and not me. So looking at engineering solutions, but not from it's specifically engineering, but I say it's
the laser.
Developing solutions. How can we produce solutions? And it's nice actually having the architectural department out here in South Africa. I'm actually aware of architects working on this exact problem from a human settlement point of view. How do we lay out these settlements, make them safer, make them more accessible, put in pathways, put in safety gathering zones, and various other things. So there is a lot of interaction between the different levels and the different people involved. So firstly, greetings from us. That's our small continent where you can fit USA, China, Eastern, Western Europe, Japan, etc. And we've got about 1 in 4 people in the world by 2050 will be African. So any big business actually needs to know, where does Africa fit in my business plan in the future? Because with a population that big and the resources on the African continent, it plays a major part in, and will be playing a major part in world economies as many of these countries become more and more developed. And we're right from the bottom, from Stellenbosch right down there. And this is where you come to visit if you're coming on a thing. That's my office, that's the mountains, and that's why some people come visit us. But it's a beautiful part of the world. But the irony is from my office there, if I walk across one of the bridges, if I look one way, I see these beautiful mountains and vineyards and such. But what's never shown on a picture like this, if I look the other direction, right here, there's an enormous informal settlement. I mean, many thousand people staying there. And that's the massive contrast you see in a place like South Africa, where you have absolute poverty next to absolute wealth. And how do we deal with this, and what can we do about it? So first we're going to look at informal settlements in context, following on from what Rodney has told us. Then look at the Imizamo Yetu fire disaster, a very large event, which gives you just an idea of what can happen. How do these fires spread? What do the fire brigades need to respond to? And general weird and bizarre things that you would never have thought about have to be addressed in response issues and everything else. And then research, some of the research topics we're working on, and then what do we want to achieve? I mean, so what, you're doing research, but where are we going with this, and what do we hope to get out of this issue? This is one thing I often like looking at, is where's the world going? We've got 7.5 billion people now. The UN estimates is about 11.2 by 2100. Our slums in Africa, within, I think it's about the next 50 years, will double in size. We already have some of the biggest in Africa. I mean, just in Cape Town, we've got about 1 million people living in informal settlements. Where are we going to put all of those people? We do not have the resources worldwide. I mean, fair enough, if there's a global war and nuclear holocaust and whatever, that won't happen, but those are the current projections based on what we're seeing, and it's a scary picture. And it's something we actually have to plan for and start dealing with. We should try to get rid of them, but we also have to acknowledge at some stage we can't. So this is just a settlement. Our international airport, one of the most beautiful airports in the world, is right just across this highway. Just look at the date. 7th month 2014. 6 months later, that's what it looked like. An entire settlement popped up in the space of 6 months. People invaded the area, and once they got settled, and everyone in the denser settlement said, hey, great, and they followed suit. And it just got denser after that. So by 2017, that's what the whole settlement looked like. But think of that now from a town planning point of view. You have no roads, you have no infrastructure, you have no hydrants, you've got nothing. But you've got thousands of people that is now home. We call them shacks, they call it home. And that's where they live, work, etc., etc. And we have to now see how do we deal with this and at least make it more sustainable. So just looking at a couple of issues, I don't have time to go through all of these things. This is a schematic of a typical dwelling. Walls and roof made from corrugated steel sheets, timber planks, plastic sheeting, or anything. If it can be used, it'll go. That's why I laugh at the American homes. You've got things lying around outside your homes. I was in Perry, and it's like, geez, if this was South Africa, all of that would have been stolen by now. You leave something, it would all be gone. I can promise you. Okay? People are very trusting. And then unsafe lighting, heating, and cooking sources, candles, paraffin, stoves, braziers. You've got unsupervised children. People go off to work, the kids are home, they knock something over. Then for security reasons, you've got doors and windows, burglar bars across. This thing's giving a bit of problems. Long distances to access roads. So even when this catches fire from the fire or from someone having alcohol, whatever it is, it's very difficult to access it and then put the fire out and suppress it. Then inhabitants tend to extend their dwellings into adjacent open areas. So even if there is an aisle between, your cousin from the rural area comes to live with you, you have another son, whatever happens. So you make your dwelling a little bit bigger and you just move your wall out, add on a bit, or you add on a bit and you rent it out. So at least you can get $40 a month income from whoever stays there. So there's a weird and wonderful, bizarre group of things you have to think about. Even if it comes to electrification, do apologize, electrification. So we put in electrification to try reduce the risk of dangerous power sources. Those are all illegal electrical cables. I mean, it's just normal wire you'd use in your home. And those run 100 feet to a dwelling across hot tin roofs and can easily cause fires. And I mean, I think there's about 50 lines going off. It looks like a spider's web. I took this photo a week and a half ago. So what I'm going to discuss now is a case study. This was one of the largest fires in the Cape Town area. It's not the largest, so we've actually had worse than this. So we had 2,190 structures, 97 structures destroyed. 2,200 homes. 4 fatalities, so the number of fatalities is actually relatively low for the size. 9,700 people left homeless. You've got 10,000 people being left homeless in one incident. Extensive damage to local infrastructure. It's about $10 million worth of damage. That's just to the city of Cape Town. That's just what they are spending. Never mind the inhabitants, never mind what the 10,000 people lost. That's just municipal costs. It's estimated that's probably the real figure is close to $15 million that it's cost the city. 176 firefighters, 2 helicopters, 13 and a half hours, and 19 acres of damage. So what happened is this settlement's actually next to a very wealthy upper income area called Hout Bay. If I turned right or left, you'd see either wine farms or yachts down in the bay and large houses in very beautiful areas. And in the midst, right on the area, on the side of the mountain, you've got this steep terrain, very rocky, difficult access, one road in and out, and there's about 50,000 people living in the settlement. So extremely dense, very high levels of poverty, people from all over Africa living in there. So you've probably got 15 to 20 different languages spoken in that little settlement. And this is the aftermath of the fire. And it started here at around 11 to 12 o'clock at night. By that time, they received the first emergency call. The Hout Bay Fire Station was dispatched immediately, parked, and ran a line. I want you to picture what you would do now. You are standing right here, and your home is burning. Everything you own is in that dwelling. You do not have insurance. You do not have a family that's going to come stay with me. You're on there. You have to survive. But the fire brigade is there, and they're fighting it strategically. They are not fighting your home. So what do? You take it into your own hands and you cut the hose. At plus minus 040, fire hose cut. At this point, it was almost under control. The fire brigade seemed to, it looked like it was just about to get there, and only, let's say, 50 homes would have been damaged. But unfortunately, then the water was rapidly lost. They had to run a new line, and it soon got out of control. It spread further up. They ran a new line. Another team came to help, but by this stage, the wind had started turning. So initially, the wind was up, it turned, and it started blowing it across. More teams and more teams arrived. The time at the bottom, you'll see going across. The new team started setting up, but by that stage, it had grown, and it just kept pushing back and pushing back. And so they were really fighting a losing battle. There was a hydrant, but not enough pressure, so the teams going at it, and people started evacuating, but they blocked the routes, as you saw earlier. Then the water tenders, the tankers couldn't get in and out to fill it up, and basically it got very nasty very quickly. By this stage, it hit this line of blue gums, sort of these trees, and once it hit those, I mean, they're highly flammable, dry season, and then it really started moving. So about 7:30, reached the fire line, fire spread and became extremely dense, and then it just started pushing down the hill. Fires normally burn uphill, but just because of the terrain, the wind, etc., it just burnt gradually down the hill. It would actually burn a lot faster had it been uphill. And this is what the terrain looked like. This is the photo I took a week ago. I mean, first you got all the electrical lines, but you can see the difficult terrain. It hit the tree line and it just moved gradually from one house to another down the hill, and the wind propelled it. Also, there may have been flaming brands that were blown and started new fires. And that's what it actually looked like during the disaster when it hit the trees, I mean, right up close. And it's very difficult addressing that. So, as I said, that's where it started. And then it started moving out by 7:30. By about 9 o'clock, it had reached down here. They started aerial bombing, but still, I mean, you shouldn't use helicopters for small dwellings. The rotors can actually knock the structures flat, and when they drop a whole bucket of water, you could kill people inside, but they really just didn't have an option. So they continued. By 11 o'clock, the fire line had moved down, and then further down, and this is where they finally got it under control, along the line of brick structures, and they could bring enough backup. And there was also easier road access to bring in water. So that's a sort of level of complexity, difficulty, and just size. It could have stopped right there. It could have been 50 homes, 10 homes, and that was that. But because of all the social interactions, it had a major influence on the response effort. So you've seen these earlier of people responding and taking things in their own hand, people evacuating. And I mean, no, you've been doing a little bit of work on evacuation and training and such. People, what they'll do is then they're trying to save all their dwellings, so they'll move them into the very narrow aisles available, and the very narrow aisles just become blocked up. Or what will happen, they'll move their stuff out there, they'll go back for more, and when they come back, it's actually been stolen. That's the nature of these sorts of communities. And what happened in the interim is that now there was a settlement that was set up to house people while they were trying to sort this area out. So this is from the top looking down. Temporary area cleared in January 2018. The fire was March 2017. It took 9 to 10 months before they were able to clear the temporary housing, and then they still moved them somewhere else. So this is a real long-term problem that's being addressed, and it's still going on. This area is still a little bit of a disaster zone and very highly political. Because as I said, fire is political, and that is the ruling party of South Africa, so that would be like your Democrats or Republicans or whoever. And that's their old head office. If you look closely, it's been absolutely torched. So they felt that their local councillors were not looking after them, so they went and torched the head office of the ruling party, and then they torched all 7 councillors' homes. So the homes just are shells. So it's one way of dealing with politicians, I suppose. It probably promotes service delivery, but it's a little bit vicious in Africa, and it's the way we do it in Africa. It's a bit scary. It's the same thing. You find a lot of arson. If someone cheats on you, you go burn them down the home with them inside. It's rather savage. So adds to our fire problem. So, but what about this? I mean, we've got this very bizarre, complex issue happening. We cannot make this go away. I mean, we basically have to provide jobs and homes for every person. That is the long-term solution. But as I said earlier, we have to acknowledge that this is something that's ongoing. So how do we deal with this? How do we at least reduce the impact of what's on the way? So there's various things we've been looking at Stellenbosch and in conjunction with Rodney and various organizations. I mean, developing tests, understanding how do they burn, how fast, what are the temperatures experienced, what does the difference of construction material make? So if someone comes up with a new product, construction material, walling system, insulation, whatever it is, I've heard some really bad ideas. They developed a spray-on polyurethane, like your normal foam, and they beautifully insulated a number of homes to make them warmer. Polyurethane is oil-based. So you've basically just sprayed the home with highly flammable, and they got funding and they rolled it out in 80 homes. And so we now have 80 homes in one of the settlements that's basically waiting to go up in smoke. So yeah, it's a little bit scary, some of the solutions we see, so trying to document and provide the evidence. So understanding fire dynamics, we've busy developing a standard shack fire test. This is one of my PhD students. He's been working on this. This is great fun for research. You get to like torch stuff. He's loving it. So we built 3 homes, and this is one of many tests that's been happening, and started the fire there, and it slowly got going. It took a little bit to get it going, get the wood on fire. As soon as it hit the combustible cladding, the cardboard around the side, you rapidly led to full engulfment, and then from there it popped across to the second dwelling, and then second dwelling got engulfed. This is a fire tornado. It actually created a vortex. There was so much heat being created in the fire, and then it soon spread to the third home, and then ignited. And at this stage, we were absolutely panicking. We thought all our equipment and ourselves were going to get cooked. Rodney was standing on the roof here in his cell phone, and everything shut down. But that was sort of the behavior we saw until we got to full burnout at the end. I mean, the homes were totally destroyed in a matter of minutes. And this is from an infrared camera looking at it. That was just the side. That's what we could see. That was the temperature in degrees Celsius. And you'll see now in Fahrenheit, I'll show you that it's about 2,000 Fahrenheit. That's what we could observe from the outside. And inside, it was actually worse. What you see is that it started off, there was a period of going up. It took a while for the wood to slowly catch fire. And then once it was engulfed, once it started reaching combustible side cladding, rapidly got up to about 1,100 in the first dwelling, 1,200 in the second, 1,250. So I mean, that's 2,300 Fahrenheit. That's the temperatures that were actually encountered. It's massive. I mean, we had the steel poles we were using for equipment were actually glowing red at the end of the test. And that's what we're trying to document, to try and understand fire dynamics and then spread beyond that. How does it behave? How does it go from one to another? And how do we stop it? Computer modeling. So now we've got a dwelling. How does the smoke move? How does the behavior, how does the influence of all these openings influence and air getting sucked in and out? That's more for then understanding smoke detection and all these sorts of things. And then modeling the fire as it behaves inside. What may we experience? What would we need to design for? So yes, you've developed a new product. Let's have a look at what it might be exposed to. And also long-term, what we want to do is develop this into large-scale models to predict spread through an entire area, to try estimate how an area might actually burn down. This is just comparing the different temperatures, and depending on what your construction material looks like, it's very different. This is representative, so that was the one Rodney showed earlier, where it was sort of a real shack, and that was then pure timber fuel load, looked like that. So you have very different fire histories, very much faster take-up, versus slow, gradual timber. So even if you change what's in your home, the amount of time you have to get out changes drastically. And then we've done computer modeling as well to predict it. Because as soon as you add in that cardboard to the side, it's a different animal. It goes up so fast. Once it licks across the side, and then whatever's on the floor just spontaneously combusts, and you have a real disaster on your hand to try deal with. So that is some of then the work on fire dynamics. Smoke alarm testing as well. There was various devices being developed. But there's a lot of questions now. How do we take this further? Bug infestation. Bugs are a huge problem. You set this up and then you find spiders in the thing, and then they shut it down. So can we redesign the housing? What about these normal room like this? It's up on the room, it's well away from even your homes. They're sort of remote. But in a small dwelling, it's right there. So can we also design buttons that you can push it? Okay, I know I'm about to cook. Let me just quickly reduce the sensitivity for 20 minutes. How long does that time need to be? How do we engage with the people's cooking habits and heating habits so that we don't have millions of nuisance alarms, so they just eventually chuck them out the window and say, it's bugging me too much. And so there's a lot of questions that need to be asked from a research point of view, from a technical point of view, from an activation, sensitivity, housing, social. All these things come into it, looking at how do we deal with it. Other research ongoing. How do we, as I was mentioning earlier, how do we start predicting spread? This is a settlement right, the ocean's actually right here. If a fire starts there, can we estimate, we'll never get this exact, can we estimate how fast the fire spreads from one dwelling to 100 dwellings, to 500 dwellings, to 1,000 dwellings? Can we estimate what the fire brigade may need to respond to? And also, if we put in a fire break, if we put in another fire brigade, another station nearby, what gives us the best bang for our buck? The problem is we don't have the resources to solve this. So we need to hone in on that intervention, solution, whatever it is, that most cheaply gives us the best solution and the fastest reduction in problems. So that's what we're looking at, sort of global modeling. And what's interesting is the fire behavior. Normally in a traditional building, you model it in one way where you've got a fire and it spreads from room to room. Where in it behaves almost in a more wildland fire. We've got this continuous bit of fuel and it burns from one to another. Your firefighting strategies are very different from a wildland fire because you've got humans and all sorts of other things. But the burning pattern is very similar to wildland fire, and how do we start addressing this? And then even there's some work, we've got a project with the University of Edinburgh at the moment, and this is looking at how do we apply technology to this problem. So this was another big fire, and you can do this at home. You go into Google Earth, go to a big settlement in South Africa, and you just track the historical images. And suddenly you'll see a whole settlement go shiny, or a whole part of the settlement get very shiny. And that's because their dwellings all burnt down. And then when they were replaced, if you've got new materials, they're often issued new materials, you'll first put the new materials on your roof. Or if you're buying, you'll use the old plates on the side and the new ones on top to reduce reduce leaks. So what you have is you have this major change in shininess, albedo, between the before and after scenario. And so the team in Edinburgh is actually developing algorithms to track that. Currently it's on a 30 by 30 meter grid. That's the pixel size from the satellites, and there's regular updates. But the satellites will soon have down to about between a 6 and 8 meter resolution. And you would actually have a per house pixel. And if you track an algorithm over time, you can see when that shininess changes. And if you run it across the settlement, say, okay, Khayelitsha, Nyanga, whatever the settlement is, over 2005 to 2017, we had 2,100 homes at such and such a time, the average. So you can start getting better estimates of the impact, time periods, and what we are actually dealing with, and then also quantify how might we do it, where is it happening, or do we have hotspots? Because certain areas, especially where young single men are normally the problem, young single men, wherever they are, that's where the problems you typically find, and how do you deal with that? So what do we want to achieve out of all this? How are we going to take this forward? Because, as I say, I mean, this is not a problem that's going to go away overnight. The settlements are growing faster than we can deal with it. So where are we looking at going? Firstly, this is a very useful academic, intellectual thing, understanding shack fire dynamics. If we understand the fire behavior, then we can start evaluating solutions. Yes, your paint product, your walling system, that's actually a really bad idea because of A, B, and C. But to document and understand the physics of shacks and how they behave. Then to model spread. How might they spread from one to another? So once again, will your product, will your system, will your smoke alarm, your sprinkler system, whatever it, will it work? Then looking at developing a standard shack fire test. We've actually made good progress with that. Hopefully later this year we can roll that out and have a testing system to run through the different options that are available to us and see, do these different ideas work? Because, I mean, Rodney gets, I think, an email every week or every second week. Some inventor has developed a new paint product, solution, warning system, whatever it is, for I've solved your problem. I've thought about it and I've solved this problem. And often they just don't work, but we need evidence to either show they do or don't. Understand the social issues. The social issues are massive. In the project with Edinburgh University, we've got 2 social scientists on the team looking at it, and then we've also got social science at Stellenbosch who've been involved with this for many years. As I said, investigate and test solutions. How do we test it? How do we find out what does and doesn't work? Document findings. That's really important. We have brigades with huge amounts of experience, but it's not documented. They know how to respond, how to interact, what they might experience, but we need to develop protocols. And this doesn't only apply in settlements in South Africa. You now have refugee camps that host 300,000 people. Some of the world's biggest refugee camps. That's what, Greece, Turkey, those parts of the world, they've had some big fires in informal settlements, in refugee camps. And there's a lot of similarity in the types of dwellings, types of disasters you may have. So to find and pass that learning on to others. And even places in North America, there's sort of settlements that have a lot of similarities. Then to be able to advise government agencies, NGOs, develop, and this is out of this, there comes some other benefits and things we're working towards. We do not have a fire engineering program in Africa. Design, understanding, physics, base, any of that. We do not have it. So we're trying to use this also as a springboard and a platform to develop our fire engineering program. So we're just starting to take in students on the structural fire side, but also now within the next years we're hoping to be able to take in pure research students on pure fire engineering, fire dynamics, fire behavior, etc. And then our structural fire engineering program is now actually getting up and running. So I've got students doing testing and such. But this all fills that as sort of an added benefit of what we're up to. So there's various things and various issues on the go, and just lost it. And so with that, we've got a couple of minutes now, so we'll wrap up there. So just in summary, it's I think you see the scale problem. Cape Town is worse than most of the rest of the country because of our climatic region, hot and dry, but still this is a major issue we've got to face. And so at this stage, if there's any questions anyone has, we can just discuss it. Otherwise, we will be having, I think, a bit of an interaction outside afterwards. So yeah, I'll open the floor now. If there's anything, where's Jean gone? She's disappeared. Maybe it's outside to prepare. But are there any issues, questions, comments, thoughts, ideas that you would like to bring up at this stage that we can chat about, ask about, anything like that? Good question. Rodney, do you want to answer that?
So they're obviously made in China. We don't have a very big market in South Africa for smoke alarms, so we have to import the one with the long life battery. So we import it from the UK for
about $12.
Yeah.
It's 150 Rand.
Yeah, it's a little bit more now. But yeah, call it about 150, 160 Rand. And that's delivered. So it's actually very cost effective. And that's the long life with the hush button photoelectric. It's the Kiddie brand.
So, but yeah, if you're talking those sorts of numbers, the ideas with the research project we're hoping to get going is actually to design a specific housing to keep bugs out and do all sorts of, and then mass produce them. Because that's actually what you need to. You need a very, very mass produced solution that you can then roll out in settlements. The numbers vary in South Africa, but it's anything between 10 and 20 million people we've got living in informal settlements, depending on how you quantify and how you identify them and such. Any other questions? Yeah.
We talked a lot about materials and smoke alarms, but one of the other biggest issues was just the way that the settlements were built up. You know, like you said, the streets get really crammed. How do you address that kind of issue?
With great difficulty. Land is a premium, and especially in Cape Town, there's a lot of pressure to find land. If you're a landowner, you can sell it for a fortune if put up nice dwellings, etc. So the city is always short of land. So putting people in anywhere is a big issue. Keeping the streets open is an issue. Some areas are better than others with keeping the municipal control, that they can then go enforce different regulations. One of the big challenges about informal settlements is their very definition is they do not comply to codes. So now, what code do you apply? Is a meter enough? Is 2 meters enough? Or what's it, 3 feet, 10 feet, whatever it is. It's distance between, I have to convert to American. What safety distance is acceptable? I mean, fires can jump 100 feet easily. I mean, with the wind going, it'll blow brands, but just to reduce the risk, and how do you even enforce it? There are ways and means of doing it. Some have been more successful. They have tried an effort called reblocking. What you do is you move an entire settlement, and you reconfigure it that you can put in roads and access ways instead of having them all over the show. Let's just see if I can get it from one of the slides. You can only do this if you have community buy-in, but you would take a settlement and then you do a reblocking exercise where you basically get them, they buy it, and you put in roads and walkways and such. But then people have to be willing to move into a different area, and then you sort of pack them in a different way so you have more space and then you can open up roads. That has showed some level of effectiveness, the reblocking, and that's actually where the architects I mentioned earlier have actually been very involved. The challenges of that is now you have all these people, and so, okay, we're going to move you. No, but I want that stand. No, I want that stand. No, I want that. But I used to have, hundreds or however many square feet. Now you've given me however many square feet. I want more, less, whatever. And then also, if you want to, let's say now, redevelop this area, between also there and there can be about 3 to 4 days. From burnt out to homes rebuilt. You're talking days. This is not 6 months, a year. That can be a couple. As soon as they get the materials, the homes are rebuilt. So you do not have time to get in and actually just reblock the area. But so what they have done before, so you'll take this section, reblock it, so they'll go live with other members, and then they'll put in the infrastructure, and then they move back. And then you take this section and get in. But it's an ongoing process. It takes a lot of engagement with the community, a lot of buy-in, and quite a bit of time and effort and resources and such. So that is a plan that's happening. Ultimately, we need more permanent structures, but also with lack of tenure, it becomes a bit, you don't want to upgrade your structure if it's just going to burn down. So there's a whole thing. So I don't know if that wasn't really an answer. Was I? Well, we don't know. So yeah, but they are, the South African government does have a program for the Breaking New Ground, which was historically called the RDP program, where they're trying to provide homes. And back in about 2000, they said by 2015, informal settlements will have been eliminated. By 2017, they're bigger than they were ever before. We've got 1 million Zimbabweans living in the country. We've got settlements growing. So we're not keeping up. They are building these low-cost housing and giving them to people. We're just building them slower than we're growing. So, any other queries, comments, thoughts?
Have they ever attempted to, instead of reblocking, doing a water grid where you increase the points of water accesses within the community itself? That way you can find themselves. That way it determines their behavior.
So if you didn't hear there was a question about what about providing more infrastructure, say saying water points and such across it. That is a possibility, but one of the challenges with these sorts of settlements going back is they spring up so fast that they inherently don't have the infrastructure in place. So now that happens, and then it rapidly becomes that. And now you're trying to run water lines. How do you get a water line? So either you've got to force people off their property. In the South African property law, it's very difficult to remove people from their property once they've been settled there for more than a very short period of time. So if you want to run our lines up, you almost have to wiggle your bulk sewer line, your water line up. It is being done, and it is showing some amount of effectiveness, but it's very difficult to bring any form of bulk infrastructure. Yes, the providing water does help, but one of the other challenges is then if you've got multiple water points across the settlement, fire breaks out, then everyone opens the tap and the pressure quickly drops. So you sometimes don't have enough pressure to then fill your buckets fast enough. So all of these things help. Water helps, reblocking helps, but it's we need a range of solutions to reduce it rather than one solution to eliminate it. Yeah. Any other queries, comments, thoughts? Yeah.
So how do you really gain the relationship with these communities to actually begin addressing these issues?
Good question. I think, Rodney, you're probably better at answering that.
So we tend to work, well, in my case, with NGOs and other organizations that already have a strong community have already done a lot of community engagement. have obtained their trust from the community. So there's many NGOs that are working in every informal settlement across South Africa. So we identify the high fire risk communities. We'll then have a look at if there's a community-based organization or an NGO, or if the fire department has a good relationship with the community. We'll then engage with the community leaders, the ward councillors, in conjunction with those organizations. So it'll be a whole process of making contact with them and meeting with them, discussing the issues within the community. We may want to help address something else before we directly address the fire problem. Maybe look at trying to create some kind of employment. We have another program called the Expanded Public Works Program, which is a poverty alleviation program. And we can actually use that program to employ people from the community as firefighters, which is exactly what we did when we used the fire department. So those individuals that you saw there were actually employed from that community. So in a way, it kind of addresses, the poverty in a very small way, but that also helps to gain trust, because then they see, we're actually there to help and not to just do research or something else like that.
I'm afraid our students might not know what an NGO is.
Oh, a non-government organization. NGO is a non-government organization. So the Red Cross,
or
American Red Cross would be an NGO. And in fact, the South African Red Cross do a lot of work in these. In fact, we also work with them, so because they work in many of these communities and deal with things like fire and the result of that.
Yeah. Great, but it's a very long and ongoing process, that building relationships. And often there's tension between the fire brigades and the communities, because whatever the ruling power is, often the municipal services are associated with the ruling power. So if you don't like, if you don't like the Republicans or Democrats or whoever's in power, you kind of associate the fire brigade with them. So the fire brigade often gets rocks thrown at them. They literally arrive at, you're too late, or whatever reason, or they put out a fire, they're on their way home, and suddenly a brick hits the window. And you have to deal with things like that. So the trust buildings can be very difficult in these communities.
Are there any kind of, government-sponsored ways to fight the, poverty, like the cause of this, like jobs, to provide,
I'll leave.
Businesses, education, community leaders, just kind of, so that these kind of things kind of stop at this point.
Rodney, you want to answer that?
Yeah, well, that's another whole
I'll
problem
leave
on
that
its
to
own.
you.
Look, there are programs, like I mentioned, the Expanded Public Works programs. There are many programs that directly try and deal with the poverty and alleviate poverty. But as you can appreciate, this is a very complex problem, and we also have corruption in South Africa, and that unfortunately it has a significantly negative impact and a ripple effect on a lot of the work that people are trying to do to deal with poverty. So yes, I think the short answer is there are programs, and there are many different programs, some of which are maybe a little bit more effective than others, depending on which areas they are being applied in the different parts of the country at any given time.
But the fact that our economy has taken a major few knocks in the past few years has had a huge impact on it. Our mining sector and various other things have taken off. And it's just had this massive ripple effect across the country, linked to all sorts of political and social and various other issues. And we need to get our economy going, ultimately. Great. I think, should we wrap up?
Thank our guests for really opening our eyes this evening to a pressing issue worldwide that here in Stillwater we don't have the opportunity to think about very often. So thank you very much.
Thank you.